गुड मॉर्निंग स्टूडेंट्स। देखिए वी वर डिस्कसिंग अबाउट द वर्क और हम वर्क के बारे में हमने बेसिक आइडियाज देख लिए थे और हमने उससे रिलेटेड कुछ 2-3 क्वेश्चंस भी कर लिए थे। आज की क्लास में हम वर्क के बारे में पढ़ने वाले हैं और बाकी चीजें देखने वाले हैं। यस देखिए यस राइट डाउन अ फोर्स F vector is equal to 6x square I cap plus 2y j cap is acting on a body of mass 1 kg and it displays from 0,0 to 1,2. Calculate work done by force when it moves along y is equal to x square path. राइट तो देखो इसमें मैं क्या कर सकता हूं। सो फोर्स इज दिस मच एंड वी हैव गिवन दिस and is moving along it. So we have to calculate work done. So what is GW? That is F dot ds. Now what is F dot ds? That is 6x square into dx plus 2y into dy. Now x is varying from 0 to 1 and y is varying from 0 to 2. Integration of dw is w. What is the integration of 6x square? That is y square by 2. So it will become 1 by 3, 4 by 2. That is 2 plus 4. That is 6 joule. So 6 joule is the answer for that. Right? So we can calculate like this. Clear? The next same question ले रहा हूं बट अब इसके अंदर एक छोटा चेंज कर रहा हूं. A force F is equal to 3y I cap plus 6x square j cap is acting on a body of mass 1 kg and it displays from 1,0 to 5,4. Calculate work done by force when it moves along y is equal to x path. राइट देखो इसको मैं कैसे कर सकता हूं. देखो हमारे पास फोर्स के गिवन है. व्हाट इज द फोर्स गिवन? दिस टाइम द फोर्स गिवन इज 3y I cap plus 6x square j cap. right? And we have given the work done. What is dW? It's a variable force. So dW is F dot ds. And if we integrate it, then it will become 3y into dx plus 6x square into dy. Integration of dw is w. What is the integration of 3y dy? That is from y is equal to x is equal to, x is varying from 1 to x is equal to 5, and y is varying from 0 to y is equal to 4. Now, but it is given ki here x and y, it is an integration of 3y with respect to dx, and that is not practically possible. And this is the integration of 6x square with respect to y. That is also not possible. But we have given it is moving along the path y is equal to x. If it moves along y is equal to x, then put y is equal to x there, because we are discussing the integration of this. It will become 3x into dx six y square into dy What is 3x into dx? That is 3 into x square by 2. Now, what is 6y square into dy? One to 5 So it will become 3 by 2 is common. X square is 25 plus 6 into y cube by 3. Y cube is 4 cube. एक चीज मिस हो गई है देखो. And that will remain -1 plus that is 6 into 6 by 3 4 cube. 4 cube is 64 minus 0. That will become 24. 36 plus 2 into this 128. Joule. Is it clear? So we can write like this. For the given relation, we can calculate the value like this. देखो next. Now we are discussing on the basis of graph. देखो, a force is acting on a 2 kg mass and varying with time as it is a 10 Newton force. And it is 2 seconds. 5 seconds. Nine seconds. This is of minus 10. आपको निकालना है कैलकुलेट वर्क डन बाय फोर्स it is with timing, it is with distance. In first nine meter and in total displacement. Right, it will be like this. तो देखो हमको क्या पता है, हमको पता है वर्क डन इज बेसिकली द एरिया बाउंडेड, दैट इज द, अगर मेरे को 9 मीटर में निकालना है तो वी हैव टू कैलकुलेट दिस एरिया and above principal axis it will act as positive and below principal axis it is taken as negative. ये नेगेटिव तो ये पॉजिटिव, ये नेगेटिव. सो व्हाट इज द वर्क डन in first 9 meter, that is the area bounded by this graph. What is the area bounded? If we look at this, so there are two triangles and one this. Triangles का area same रहेगा, अलग अलग रहेगा. It is different because it is 2 meter, it is 10. So it is half base into height. That is 10 into 2 is 20 by 2. That is 10 बचेगा. And this is 5 to 2. This is 3 and this is 10. 10 into 3 is 30. So it is 30 and this is how much? 10. 30 plus 10 is 40. And this is how much? This is 4 and this is 10. 40, 20. So what is the area work done? A part. Work done in 9 meter. Area bounded by graph. What is the area bounded by graph? This is half base into height, that is 10 joule. $30 joule. Joule. And this is positive 60 joule and in 17 meter. This is 60 joule and this is how much? Half base into height, that is 10 into 4. That is for 20 and this is 40. So it will become 60 minus 40. That will come out to be 20 joule. Is it clear? So that is the work done by the force. Next is work done by spring force. This is the mass connected to the spring. M is connected to the spring. And it is in natural state. मान लो इट्स गेट डिस्प्लेस्ड बाय सम डिस्टेंस. Now it displaced by x. The force is acting opposite to it. K into x. So, spring force is a variable force. Whose magnitude is changing with x. Now, अगर मैं इसका वैल्यू निकालने जाऊं, Fs is k into x. तो dw is f dot dx. Now the displacement is in forward direction, it is in backward direction, the force. So it will become into dx. Now what is force? Minus kx into dx. This is dw. So I'm writing dw where integration is w. That is work done from that is initial to final, and then become minus k x dx is x square by 2, x initial to x final. That will become minus k So work done by spring force from initial to final is, that is half k x initial का square This is the work done by spring force. This is the work done by spring force, right? लिखेंगे इसको. Next. Next, write down the question related to it. A block of mass m is connected to a spring of force constant K on a inclined plane. Inclined plane as shown in figure. Is in equilibrium as shown in figure. An external force is applied so that it reaches to its natural position. Calculate work done by spring force till it attains natural position. This is the figure for it. The spring is displaced by some distance from its natural position. This is the natural. We know when it comes to rest, it is in equilibrium position now. So there are two forces are acting on it. The mg sin theta is acting there, and F is equal to K into X. Is acting in this direction. This is X. So what is the solution for that? So you can write mg sin theta is equal to Kx. So X is equal to mg sin theta by K. Now when it reaches to its natural position, then its x displacement So what is the work done by spring force? X initial is this much. This is the displacement. This is the work done by the spring force from final to initial. Is it clear? Next question लिखो जी. A uniform chain of mass capital M and length capital L is placed on a table such that its 1 by nth part is hanging. Calculate work done by external force applied parallel to surface of table so that whole part of chain reaches on the table. Slowly. This is a question. ये चेन है कोई, जिसका 1/n पार्ट हैंग कर रहा है शुरू में। Ln पार्ट हैंग कर रहा है, बाकी पार्ट ऊपर है, तो मास भी पता है। एक फोर्स हम लगा रहे हैं विच इज अप्लाइड इन दिस डायरेक्शन, इसको ऊपर खींचने के लिए, इसको ऊपर खींचने के लिए हमें एक फोर्स लगा रहे हैं इस डायरेक्शन में, और इसको स्लोली खींच रहे हैं। अगर स्लोली खींच रहे हैं तो इट मीन्स एट ईच इंस्टेंट ऑफ टाइम यू कैन से दिस थिंग कि द इक्विलिब्रियम इज अचीव्ड, कि जो फोर्स लग रही है वो इसके बैलेंस होगी। अगर ये चीज़ ऐसे बन जाएगी, मान लो किसी टाइम पर उसका एक्स हिस्सा लटक रहा है, ये जो लेंथ इसकी लटक रही है ये एक्स है, इसका मास कितना होगा? टोटल मास m है, पूरी m/l मास पर यूनिट लेंथ इंटू एक्स, ये इसका मास हो गया स्मॉल m। यहाँ पे फोर्स लग रही है F। अगर इसको स्लोली खींच रहे हैं उस टाइम पर ये फोर्स वेरिएबल है। क्यों है? क्योंकि इसको चेन को देखो तो चेन के यहाँ पर एक टेंशन T जनरेट हो रही है। अगर मैं इसका फ्री बॉडी डायग्राम बनाऊंगा F इज इक्वल टू T इधर की तरफ, और यहाँ पे लग रहा होगा स्मॉल mg, इसमें T ऊपर की तरफ, राइट। तो मैं क्या लिख सकता हूँ? mg इज इक्वल टू T, और एक में लिख सकता हूँ T इज इक्वल टू F, तो F इज इक्वल टू mg, that will become m/l into g into dx। इसको y मान लो, it's a variable force. Now if it is variable, so work done by it cannot be calculated directly, but we have to perform the integration। देखो मुझे क्या करना पड़ेगा, मान लो ये है और हम इसको डिस्प्लेस करते हैं dy, तो कितना वर्क करेगा देखते हैं। तो इफ इट इज dx डिस्टेंस एंड आई एम डिस्प्लेसिंग इट बाय y, मान लो इफ वी डिस्प्लेस इट बाय dy, so that the force is not changing, so we are writing dw f dot dy। ना बोथ आर इन सेम डायरेक्शन, अगर वो आगे चलेगा ये भी ऊपर चलेगा तो वर्क तो सेम ही आएगा निकल के, तो f into dy that will come integrate it. Now if we integrate it from y varying from which to which, y is varying from, that is minus L by n to 0. M by L is constant बाहर, इसको स्मॉल ले लो. M by L is बाहर, G भी बाहर. What is the integration of y dy? So what is the answer? So work done by the external forces. It is, the limit is to be put from y, and it is to be dy is cut in opposite direction, that is will become minus dy. Being minus आएगा, तो कि y is cut in opposite direction. बाकी इसको सोल्व कर रहा हूँ आप. इज इट क्लियर? तो इस तरीके से हम इसका आंसर कैलकुलेट कर सकते हैं. दैट इज अ सोल्यूशन फॉर इट. इसको सोल्व करेंगे तो माइनस माइनस खत्म हो जाएगा, एल स्क्वायर की टर्म आएगी, एल से एल खत्म हो जाएगा, एम जी एल बाई 2n स्क्वायर. That is the work done. Right? So this is a solution for it for this. Is it clear to all of you? That is the work done by the external agent index. Is it clear? लिख लो इसको.